Today we are going to solve a problem on cams and follower. In this video we are going to solve a problem about roller follower having cam rotation with simple harmonic motion. We are also going to draw displacement diagram, velocity diagram and acceleration diagram. Now first I will read what is the given problem. A cam with minimum radius of 25 mm rotating clockwise at uniform speed is to be designed to give a roller follower at the end of wall rod motion described below. To raise the wall through 50 mm during 120 degree rotation of cam, to keep the wall fully raised through next 30 degree, to lower the wall during next 60 degree and to keep the wall closed during the rest of revolution, that is 150 degree. The diameter of the roller is 20 mm and diameter of the camshaft is 25 mm. Draw the profile of cam when the line of stroke of wall passes through the axis of the camshaft. Second, the line of stroke is offset 15 mm from the axis of camshaft. The displacement of the wall while being raised and lowered is to take place with simple harmonic motion. Determine the maximum acceleration of the wall rod when the camshaft rotates at 100 rpm. Draw the displacement, velocity and the acceleration diagrams for one complete revolution of the cam. So this was the given question. Now we will move to draw the displacement diagram with some suitable scale. So here in one complete revolution of the cam, the angle covered is 360 degree. Now we will take scale 1 cm is equal to 10 degree. That means we have to take the total distance, that is in centimeter, for 360 degrees 36 centimeter. Now on this x-axis, or we can say abscissa, we will plot here the revolution of the cam or the angular displacement of the cam. So if we observe the given question here, instead of outstroke and return stroke, wall raised and wall lowered, these particular words are used. So here this wall raised means outstroke and wall lowered, that means return stroke. So this outstroke or wall raise is given 120 degrees. So as per this scale, we have to take this distance from this is the starting line. So we have to take here 12 centimeter distance, and then for the period of dwell, that is when the follower is at rest, that is the distance is 3 centimeter for 30 degree, and next for the return stroke or wall lower, the distance is 6 centimeter for 60 degree, and here the next distance is 15 centimeter for the 150 degree. So here this is the dwell period, so I have minimized this total length. Now here the motion is simple harmonic motion. So we have to draw on the left hand side one semicircle with this diameter having the stroke length. So on this ordinate or y-axis we have to take the stroke length, and which is given 50 mm. So with this stroke length we have to draw here one semicircle, and taking its center we have to make some equal parts. So remember, we can take here any equal parts, that is 6 number of parts, 12 number of parts, 8 number of parts. So here we will take total number of equal parts for this semicircle is 6. So for this semicircle, the angle covered is 180. So 180 by 6, that is equal to 30 degrees. So each angle is 30 degree apart, and we will make here the 6 number of angles. So here 6 number of parts. So now we will give here some particular numbers. So I will give here as the starting point is 0. Then here 1 double dash, 2 double dash, 3 double dash, 4 double dash, 5 double dash and 6 double dash. So in the same way, now this number of parts are 6. So the same number of parts we have to make for the outstroke and return stroke. So here wall raised and wall lowered. So for outstroke, again we will make here the 6 parts. So for 120 degree, 120 divided by 6, that means each part is of 20 degree. So for this 20 degree with proportional scale 2 centimeter apart, we have to mark here the points. So we will give here the numbers. So here first will be 0, then here 1, 2, 3, 4, 5, 6. Then next for the return stroke. So for dwell period no need to make any parts. So again for the return stroke here we will give the numbers. So this is the return stroke. So we will give the numbers in opposite direction. That is first we will take here as a 6. So for return stroke I will use here as a single dash. That is 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0 dash. So this is to make easy for the construction. So next construction that we have to draw here lines from this 1 double dash, 2 double dash. So it is easy for us to select the points. So in this same way we have to give the numbers, that is in the reverse direction for the return stroke. Because why? Because at this last point 0 dash the ball is coming at its original state. So now what is the next construction? That is from the selected this 1 dash, 2 dash. So this from these partitions we have to draw the horizontal lines. So from this 1 dash I will draw here the one horizontal line for this out stroke and the up to the return stroke also. So we have to take the parallel lines. So from this 1 double dash to 1 dash we have to select. Now the next is 2 double dash. So here 2 double dash to 2 dash we have to extend this line up to 2 dash only. So we have to take the parallel lines. So here in this way, this is the line 2 dash. Then the next is from 3 dash. So from 3 dash, we have 3 double dash. We have to take the or extend this line up to 3 dash. Then next is 4 dash. So here from 4 double dash we have to extend this line up to 4 dash. Then next is 5 double dash. So from this semicircle there is 5 double dash. So we have to extend this line up to 5 dash. So here 5 double dash to 5 dash. Now we will select the points. So it is important part, that is how to select the points. So first at this 0, that is I will say here the letter A. Then here 1 dash is we have to select point of intersection for this path 1 for the outstroke. So I will select here this point, and in the same way here 1 double dash to 1 dash. So here is also point. So currently I will give here the letter B. Then in the same way for 2 dash, here I will select the intersection of this horizontal line with this vertical 2. That is here is point C, and here is also from 2 double dash to 2 dash. So here point is getting selected. Now 3 dash to 3. So here is also 3 double dash to 3 dash. So here point is D. Then 4 double dash to 4. So here is vertical line 4, horizontal line 4 dash. So here is point E, and here is also 4 double dash to 4 dash. So here is also point is getting selected. Now 5 double dash to 5. So here is F, and here 5 double dash to 5 dash. So here is point is getting selected. 6 double dash to 6 and 6 dash. So now A, B, C, D, E, F. So here this point is G. Here is point H, I, J, K, L, M, and here last one is N. So now we have to draw the profile. So I will draw here. So draw the smooth curve. Now during 12 period it remains constant, that is wall is getting raised at this position only, and then here it is getting lower. And then here after this for 150 degree it remains at its original state, that is we have to continue up to its dwell period of 150 degree. So this is the profile. Now we will move for the first case where the condition is given that the line of stroke of the valve rod passes through the axis of camshaft. So for that first we will draw one circle, that is the base circle with 25 mm radius with O as a center. So on this circle we have to draw one line passing through the center O in the form of dash. So as per the condition here, the axis of camshaft is the axis passing through this point O. And now the line of stroke of the valve rod. So where is the line of stroke of the valve rod? So here this is the roller follower. So here the trace point is the center of this roller. So the dimension is given. So dimension of roller diameter is given as a 20 mm. So we will take here the distance in the compass, that is equal to 10 mm, and we have to take this distance as a 10 mm. And from this base circle we will select the point on this line in the form of dash. We will take the distance as a 10 mm and that point will be center, and we will draw here one circle. So this is the initial position of the valve rod, and here the trace point, remember the trace point in this roller follower is the center. So here A is the center. So here if we observe this, the initial position of this roller is point A at the line 0. So here is also, this is the initial position. So now we will join this point O and A. Now if we observe this displacement diagram, here the valve raise is 120 degree. So we will select this angle 120 degree with OA as the baseline. So I will keep here the protractor and we will select the angle of 120 degree. And the next is dwell period is 30 degree. And the next is the valve lower, that is the return stroke is for again 60 degree. So after that we have to select the point for 60 degree. So first I will complete, this is the line and then this is the dwell period, and after that dwell period we have to select the angle of 60 degree. So again I will select here one angle of 60 degree. And that 60 degree angle will be return stroke. So here we will first complete this. So now I will give here, this is the first 120 degree, then next 30 degree, and then next 60 degree angle. So if we observe after the outstroke, so when it is getting completed at this point 6, here is the point G. So on this line, so we will again draw one circle passing through the center of the roller, and this circle is nothing but the prime circle. So I will give here the name, that is this is the base circle, and the circle passing through the center of the roller is known as the prime circle. So it is important to construct in case of roller follower. Now here at this point 6 there is the point G. So I will select here as a point G. Then at the end of the dwell period again here is the point H. So I will select here the point H, and the last point is the point N. So I will select here the point N. So as we made here the 6 number of equal parts for the valve raise and valve lower, so in the same way we have to make here the 6 number of equal parts. So I will make here, so with the help of this 120 degree, I will make here the 6 number of equal parts, that is each part will be 20 degree apart. and then for the next 60 degree I will again make here, that is we have to keep the protractor in this way, and for the next 60 degree each part will be 10 degree apart. And now we will draw the lines passing through the selected points. Now on the prime circle, here is the point of intersection for this selected lines. So we will give the numbers as in the same sequence in the displacement diagram. So at the initial position, that is at point A, there is number 0. Then for the next line it is 1, 2, 3, 4, 5. So here if we observe 1, 2, 3, 4, 5, 6. And after that, when the return stroke is getting started, then the number is 6 dash. So here at this point H, we will select here 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0 dash. Now with the help of compass, we will transfer the distance. So these are the numbers. Now we will transfer the trace points. That is here at this selected part, that is at the point 1, trace point is the point P. So what is the distance here? So we will select this distance in the compass and we will transfer this. So I will give here from this point 1 to B. So the same distance is there for this 1 dash to M. So here for 1 dash to M, I will select this point M. Now in the same way 2 to C. So here I will select this distance 2 to C. And here 2 dash to, here point is L. So I will give here L. Then 3 to D. So again 3 to D. So same distance is there, that is 3 dash to K. So I will select here this distance, that is the point K. Then 4 to E. So again with the help of compass, we will select here 4 to E and so on. Here all the points are getting selected, that is A, B, C, D, E, F, G, H, I, J, K, L, M, N. Now these points are called as trace points, and these trace points are the center of roller. So again we have to take the distance, that is equal to 10 millimeter in the compass, and we have to draw a circle by taking these all the points as a center, that is with taking B as a center, C as a center, D and so on. So if we draw here all the circles, then we will join these trace points, that is here in the form of dash, and with the help of red marker I have joined all these trace points. And if we join all these trace points, then we will get the pitch curve. Then how we will get the cam profile? So here the end points, that is the point of intersection on this partition of this selected lines and the circle. So these end points we will get here at the base of the circle, each point. So if we select this each point and we will join these lower points on the circle, then we will get the cam profile. So this cam profile I have shown with the help of the black marker. Now we will move for the second case. So we have to draw the profile when the line of stroke is offset by 15 mm from the axis of camshaft. So we know that the axis of camshaft is the line passing through the center O. So we have to first draw one circle with minimum radius 25 mm by taking center O, and this circle is known as base circle. Now from this center O, we have to draw one offset by taking a distance of 15 mm. So here we will take the distance from this vertical line passing through the center O. We will take here 15 mm distance, and at this distance we will draw one line in the form of dash. So again we will draw one circle by taking radius that is equal to 15 mm. So this circle is known as the offset circle. So I can also mention this, that this is the offset circle. On this base circle, if we observe again, this is the line in the form of dash. So in compass we have to take the distance equal to 10 millimeter, because what is the diameter for this roller? That is the roller follower. The roller diameter is given in the question 20 millimeter. So we have to take the 10 millimeter distance in the compass, and here above this line, that is this is the point of intersection of base circle with this line in the form of dash. So above this point we will select the distance of 10 millimeter and we will select the center, and from that center draw one circle so that our roller diameter will be equal to 20 millimeter. So in case of roller follower, we know that the trace point is the center of roller. So here this is the initial position of the roller, that is 15 millimeter offset from this center of the camshaft. So this is the initial position. So if we observe here the displacement diagram, this is the initial position, that is the point is A and number is 0. So we will give here, that is the center point A, and at the same time we will give here the number as a 0. So again we will draw one circle passing through this point A, and this circle is known as the prime circle. Now as per the given data, that is the wall raised is equal to 120 degree, then dwell period 30 degree, wall lowered is 60 degree. We have to plot this. So for that we will join this initial position, that is the point A to O, and we will take this OA line as a baseline, and from that we will select the angle of 120 degree. So this angle is for outstroke or wall raise. Now the next is for dwell period. So for the 30 degree angle we will select the next angle, and then after that we will select the angle for 60 degree, that is for return stroke, or we can say wall lower. Now for the outstroke and return stroke, that is wall raised and wall lowered, we have to make the equal parts as made in the displacement diagram. That is here 6 number of equal parts we have to make. So for this 120 degree, each part will be at 20 degree apart, and for this 60 degree, each part will be at 10 degree apart. So here I have selected the points. So the numbers are given, that is after 0, 1, 2, 3, 4, 5. So we have to give the numbers as per this partition. So here if we observe, trace point is on the prime circle. So this number should be given on the prime circle. So how to give? So from this center O to this selected point, that is this is the first part at 20 degree apart, we will take one line, and here is the point of intersection, and this point is nothing but the point 1. In the same way this is the second point. So here is on prime circle, there is third point. So we have to join this point O and selected point, and on the same line we will select the point on the prime circle. So then this is the point 3, then next is point 4, then there is point 5. Then in the same way in this return stroke also we have to take, this is the first point, that is point 1, then here is the second point, then here is the third point. So we will first select these points and then we will give the numbers. So if we observe here, as in the sequence in the displacement diagram, we have to give the numbers, that is here 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, here is point 6. Now after that there is dwell period, and then the first line is for 6 dash. So I will give here as a 6 dash, then here is 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0 dash. Now these points are selected. Now how to make this profile? So for that we have to draw the tangent to this offset circle but passing through these points. So I have to draw one tangent to the offset circle but passing through this point 1. So I will draw here. Then in the same way I have to draw the second tangent passing through this point 2. Then Then here will be 0.5. So all are these tangents. So in the same way again for the 6 dash we will again draw here one tangent. So remember tangent to the offset circle but passing through these points. Now we will follow the same procedure as earlier. So from these points 1, 2, 3, 4, here are the stress points, that is B, C, D, E, F. So again 1 to B we will take the distance in the compass. So I will use here the black marker for the notation of these letters. So we will take here the distance 1 to B. So same distance is for 1 dash to M. So here 1 to B. So this point is B. So here 1 dash to M. So I will select here the point as a M. Then next is 2 to C. So here we will take the same distance as a 2 to C. So here 2 dash to L. So we will select here as a point 2 dash to L. Then again 3 to D. So the same distance is 3 dash to K. So here 3 to D I will select the point and then 3 dash to K and so on. So here all the trace points are getting selected. Now again we will take the distance in the compass which is equal to 10 millimeter because roller diameter is given 20 millimeter, and again we will take each trace point as a center and we will draw here the circle. So at each trace point there are the circles. Now if we join these trace points, so here in the form of dash and with the help of red marker I have joined these trace points, and this is the nothing but the pitch curve. And if we join the lower points of the circle, so all these lower points of the circle are getting joined and it will give us the cam profile. Now we will move for the calculation part with the help of the given data. If we observe here stroke is given 50 millimeter. So the stroke is 50 millimeter. So in terms of meter we can write 0.05 meter. Then the angular displacement at outstroke, that is when wall is raised, it is given 120 degree. So we have to convert it into rad. So how to convert it? So we have to take this value in pi, and pi is equal to 180 degree. So how we can write this 120 degree in terms of pi? So for this 180 degree, if we multiply here with 2 by 3, that is 2 into 180 divided by 3, that is equal to 120 degree. So this is the value in rad. So if with the help of calculator we calculate this, so pi value is, that is the already present in the calculator. So if we multiply with pi multiplied by 2 divided by 3, then we will get 2.1 rad. Then in the same way, for this return stroke, the angular displacement is given, that is for the 60 degree, or we can also say for the wall lowered. So for this 60 degree, how we can write this value, that is in degrees in terms of rad. So in terms of pi we have to write this. So pi is 180 degree. So if for this 180 degree we divide it by 3, that is 180 by 3, that is equal to 60 degree. So we will write here pi by 3 rad. So pi value that is already present in the calculator. So we will directly place this pi divided by 3, which is equal to 1.047 rad. And the number of revolutions is given 100 rpm. Now from this we can calculate what is the angular velocity, that is omega of the camshaft. So angular velocity omega 2 pi n by 60. So n is 100. So if we put this value, we will get 10.47 rad per second. So we will use this omega for the calculation of velocity. So what is the maximum velocity at outstroke, or we can say when the wall is raised? So what is the formula? Pi omega s divided by 2 theta O. So here theta O we have to take the value in rad. So pi into 10.47 into 0.05, that is we have to take this value in meter, divided by 2 into 2.1. So 0.39 meter per second. So this is the maximum value of velocity during outstroke. Then again, what is the maximum value during return stroke? So v to the base r, which is equal to, again we will use the same formula, but instead of theta O we have to use here theta r, that is equal to 60 degree, and that is equal to 1.047. So again pi into omega into s divided by 2 into theta r, that is 1.047. So which is equal to 0.785 meter per second. So these two values are important to draw the velocity graph. So when we draw here the velocity diagram, then these two values, that is, this is the maximum value during while raise and this is the maximum value during while lower. So these two values are important. Now in the same way we will find out what is the maximum acceleration when the valve is raised or outstroke. So for the outstroke we will use here the suffix O, that is AO. So what is the formula? Pi square omega square s by 2 theta O square. So all the values remain same, but we have to take square, that is pi square omega square and theta O square. So value is 6.13 meter per second square. So this is the value that is also important to draw the acceleration diagram. Then in the same way, maximum acceleration value during return stroke, that is AR. So same formula is there, that is pi square omega square s divided by 2 into theta r square. So here theta r we have to use 1.047 square. So when we calculate this we will get answer 24.67 meter per second square. So these two values are important for drawing the acceleration diagram. So we will refer these calculated values and now we will move to draw the diagram. Now we will move to draw the velocity and acceleration diagram as per the calculated values. So for that we will first draw the horizontal line with the same scale of this displacement diagram. For the velocity diagram also and for the acceleration diagram also. That is, we have to select here with the same scale for outstroke, that is the line is equal to 120 degree. Then for dwell period and then for return stroke, that is the length is equal to, that is proportional to this 60 degree, and again there is the dwell period. So in the same way there are velocity and acceleration diagram, both these horizontal lines are getting completed. Now if we observe the maximum value of velocity during outstroke and return stroke is here, that is 0.39 meter per second and 0.785 meter per second. So for that we will select one proper scale, that is 1 meter per second is equal to 10 centimeter. So for this 0.39 meter per second it will become 3.9 centimeter, and here for 0.785 meter per second it will become 7.85 centimeter. So now we will first move to draw the velocity diagram with the help of these two values. So this is the maximum value during outstroke, that is VO, and maximum value during return stroke, that is VR. So when the rotation is taking place with simple harmonic motion, the velocity diagram follows the sine curve. Now what is the characteristics of this sine curve? So at the starting point and at the end point of the stroke the value is 0, and at the middle point there is the maximum value that is getting obtained. So here for the outstroke or when valve is raised, the maximum value is in the upward direction is getting maintained, and when the valve is lowered, that is during the return stroke, the maximum value is getting maintained at this downward direction. So this maximum value 0.39 meter per second, that is with the help of scale 3.9 meter per second, we have to select the scale and we have to mark here one point. Then in the same way for the return stroke, so here is the period of return stroke, so this is the middle point. that I have shown with the help of red marker. So we have to take scale 7.85 centimeter and we have to mark here one point. Now we will draw the sine curve. So at the end, at the initial point and end point, the value is 0 and at the middle point it is maximum. Then in the same way, dwell period, that is the follower is at rest. So for again during the there is the return stroke, here is the maximum value. So again we have to draw here the curve. So this is the curve that is getting obtained. So now we can write here the value also here, that is this vertical distance is the maximum distance, that is 0.39 meter per second, and here also this is the maximum distance, that is we can show this value is 0.785 meter per second. So this is the velocity diagram. Then we will move for the acceleration diagram. So this is the maximum value of acceleration during outstroke and maximum value of acceleration during return stroke. So here also we will take some suitable scale. So here 6.13 meter per second square. So we will select here as a 6 centimeter distance, and here for the return stroke it is 24.67 meter per second square. So we will select here the value as a 24 centimeter, or we can also take the scale which is equal to half. That is, for this 6.13 we will take 3.06, and for 24.67 we will take 12.33. So here we will take the scale that is equal to half, and here the outstroke is getting marked, return stroke is also getting marked, and these are the middle points. Now acceleration diagram, when the motion is simple harmonic motion, follows the cosine curve. So what are the characteristics of this cosine curve? So at the initial point and at the end point the maximum value is there, and at the middle point the value is 0. So for this outstroke the maximum value is 6.13. So we have to maintain the 6.13 during outstroke at the starting point and end point, but at the middle point it is 0. So this horizontal line starts from this 0. So here is 0. Then I have to draw this cosine curve. So during outstroke, here take some suitable scale. So I have taken here 1:half. So 6.13, that is 3.06. So I have taken here. So mark on both sides of this middle line O. And now at the starting point it is maximum value. At the midpoint it is 0. So I will draw here the curve. Then in the same way, here at the end there is the maximum value. So I will again complete this curve. So this is the formation of cosine curve. So these two values indicates us the 6.13. So we can show here, that is these two values are 6.13 meter per second square. Now in the same way, for the return stroke also we will draw here the cosine curve. So for the return stroke maximum value 24.67. So at the midpoint it is, the value is 0, and at the start and end the value is maximum. So here we have to take the vertical distance with proportional scale. So 1:half, that is 12.33 we have to take here. From the starting point I will take here something 12, and here is 12. So I will draw here the line. So at midpoint the value is 0. So this is the value. So I have to show here, that is this value is 24.67 meter per second square. That is vertical line, and this vertical line also indicates the same value that we have to show. So in this way the velocity diagram and acceleration diagram is getting completed.